Hello everyone, and welcome to today's webcast, brought to you by Power Engineering. Today's event is titled Simplifying Large CAD Models for Plant and Process Design, and it is being sponsored by ITI, International Techno Group. My name is Rod Walton. I'm Content Director for Power Engineering, and I'll be your moderator for today's webcast. Before we begin, I need to cover a few housekeeping items with you. At the bottom of your audience console are multiple application widgets for you to use. Pretty self-explanatory, but I do want to point out the question and answer tab. If you have any questions for our speakers during the webcast, you can click on the Q&A widget and submit your question. Our speakers will answer questions after they've completed their presentations, but you can type your questions in at any time during the webcast. You may expand the slide area by clicking on the maximize icon on the top right of the slide area, or by dragging the bottom right corner to enlarge. In fact, you can expand and reposition many of the components on your screen, so please feel free to arrange them any way you'd like to give you the optimal webcast viewing experience. If you have any technical difficulty during the webcast, please click on the Help widget. It has a question mark icon and addresses common technical issues. If you still need assistance, just type your issue into the Q&A widget, and a member of our webcast support team will work with you to correct the problem. For your convenience, this presentation will be available on demand within 24 hours of this live event. A reminder email message will be sent to all registrants with a link to the archive. It will also be accessible from the magazine's homepage at power-eng.com. So if you want to go back and view all or part of it later, or you want to encourage your coworkers to view it, it will be available for 1 year. Now on to our program. Plant design and process engineers continually face the problem of integrating very large mechanical CAD models into their 3D design systems, which leads to wasted time, higher costs, and commissioning delays. This webcast will detail how to address those issues using automated model simplification and data reduction tools, and includes a case study with Kiewit. So I want to introduce you to our speakers today, Kurt Johnston and Andy Chinn. Kurt serves Kiewit as Engineering Applications Lead in the Engineering Design Software Support Group. He has more than 29 years of experience in the energy, civil, transportation, and BIM-related industries, including design and coordination of rural and urban highways, residential streets, intermodal facilities, commercial site development, general construction coordination, and producing photorealistic renderings and animations. Kurt is an active member of the Autodesk, GeoPack, and MicroStation user communities and serves as technical advisor to the Engineering Technology Department at Northwest Kansas Technical College, where he earlier earned a degree. Our first speaker is Andy Chinn, who is Managing Director with ITI UK. Andy has worked in the CAD and engineering analysis environment for more than 30 years, after gaining a Bachelor of Technology degree in Engineering Science and Technology from Loughborough University. He's been with ITI for 24 years, based in the UK office, Cambridge, where he has held various positions including CADfix Support Manager, Product Manager, Business Development Manager, and Commercial Director. Andy is responsible for the European business, including the sale and application of ITI's engineering, data, and operability solutions in Europe, CADfix integration partnerships, and managing the CADfix European and Asia Pacific distribution network. And with that, I'm going to now turn the program over to Andy.
Thank you, Rod. Welcome again to everybody, and thanks for your time today. As Rod pointed out, we're going to be talking about the simplification of large mechanical CAD models, or MCAD models, for use in the plant and process design systems, such as the systems delivered by key vendors such as Aviva, Intergraph, Bentley, and others. In terms of the scope of the webinar, we've determined that by using CAD model simplification techniques, orders of magnitude in file size reductions of the mechanical CAD models can be achieved before they are integrated with your plant and process design system. We're going to highlight the issues that are associated with the integration of these large equipment models as they were designed in their original MCAD systems. We'll look at how the simplification can be applied and automated in a process and workflow to give file size reductions. Hopefully through the course of the webinar, you'll see how the file size reductions can lead to several qualitative and quantitative benefits built upon time and process savings that help you deliver on your project commitments more effectively and ultimately get to commissioning faster. It's a fairly straightforward agenda. We'll cover the need to simplify and the benefits that can be achieved through that simplification. We'll look at how to simplify models using different interactive and automatic techniques that are available. I'll show a couple of illustrative examples of the type of data reduction that we can achieve, and then I'll hand over to Kurt from Kiewit to discuss his requirements and experiences of model simplification in his business. So first, really, let's just look at the need to simplify. Why do we need to go through the hassle and trouble of simplifying these large mechanical CAD models? Well, your plant designs, your layouts, your schematics, they incorporate potentially hundreds of machines and equipment assemblies, maybe thousands. Now, these equipment models are usually designed by the equipment suppliers in their mechanical CAD systems such as CATIA, NX, SolidWorks, or Inventor. And they're designed with all of the detail necessary for the manufacture of those machines. It's generally far, far greater detail than you need in the plant layout, where perhaps you only need the model for clash detection, pipe routing, cable routing. Also, I mean, due to the sheer size of the plant layouts themselves and the volume of data represented, the plant design systems are often designed or developed to handle primitive shape representations of the equipment, things such as cylinders or boxes, and not the full mechanical CAD representation. So there's a very large benefit that can be gained in terms of integrating these CAD models with your plant design system if you can quickly remove these unwanted details and simplify other parts of the model and reduce the file size. The impact can be significant. We also need to consider the field users with tablets, mobile phones, and cellular connections, where the time and cost associated with downloading these large models. In this case, the small files and fast downloads are critical to the business process. Another reason to simplify comes from the developers of the equipment themselves. Quite often they need to, or they want to, protect their intellectual property invested in the machines they've designed. And to do that, they need to simplify the models before they're distributed to the customers in the supply chain. So let's just look at that schematically. Here we have an example of an equipment supplier. So this is a machine developer who has a model. Here we've got some equipment on a skid, so a large skid assembly. That mechanical CAD file, as designed in the mechanical CAD system, is about 800 megabytes. It's a fully featured CAD model with all the details. And it's going out to a systems designer, a change control engineer, and a field engineer who all need to handle that model, import it into their systems, and operate on that model. But they all have issues. The sender of the data is worried about protecting his IP. He doesn't necessarily want to send out a fully featured CAD model. The systems designer, well, he's seen how big the file is straight away. 800 megabyte file he knows it's going to be a problem. He knows it's going to slow down his plant design system. And actually, all he really needs is the overall outside shape of the assembly and the key tie-in points and pipe connections. He may be driven, because the model is so large and so complicated, to redesign it and create a primitive model himself. The change control engineer or another consumer of the data, he might have tried several times in several different ways of importing the model into his plant design system, and it's simply too big. The field engineers looked at this file, and all he can see is that an 800 megabyte file is going to take forever to download over its cellular connection. And it will probably be impractical with line interruptions and costs. And of course, it's yet again another CAD format that he doesn't normally deal with or hasn't got an interface to deal with. So there are lots of issues with trying to reuse these complex, fully detailed mechanical CAD models across the whole process chain. But there is a lot of potential to simplify these models. And this is it's a great example of where a complex equipment model can be reduced very quickly in just 15 minutes. We have a relatively small assembly model which started life as a 40 megabyte DWG file with 73,000 CAD faces in the model. That can be very quickly reduced to a 1 megabyte file with 2,000 faces. So 40 meg down to 1, 73,000 faces down to 2. This was a fully automatic process achieved in 15 minutes and a 97% data reduction. And as you can see, the model still looks the same. It's retained all of the key features for positioning with the layout and for clash detection. But I'm sure everybody will agree that a 1 megabyte file is far easier to distribute and handle around the supply chain than a 40 megabyte file. And this is really just a relatively small example model compared to many of the models that our customers have to handle that are several hundred megabytes or getting into the gigabyte range. Now, if we extrapolate that kind of simplification on one equipment assembly across the entire plant, then it could have an immense impact. Massive savings could be made. The plant will contain hundreds or thousands of assemblies, pieces of machinery and components. And if we can aim to remove or simplify the geometry across those hundreds or thousands of components, then we are looking at gigabytes of data savings and integration times of taking those models into the plant design system of hours rather than days or weeks. So you can start to see how applying the simplification of the mechanical CAD models can have quite an impact on the overall process and business benefits further down the line in terms of lead times, time to commissioning. And just looking at that back on the schematic view, we've now got a sender of the data who's got instead of an 800 megabyte step file, he's got a 29 megabyte step file of the simplified model. And that file is now much easier to distribute to the same receivers or consumers of the data. But the machine developer, the developer of the equipment, is happy because he's saved hours of manual simplification time. He's also happy because he's only shared key tie-in details and his IP is now protected. The system designer's happy, perfect. The model now contains all he needs for his digital mock-up and it has the key reference and tie-in points. Both the systems engineer and the change control engineer find the model easier to place in the plant design system, and the system is more manageable and usable with that model integrated. They also found that the model imported first time and was fast. So no remastering, no remodeling, no repeat import attempts. The field engineer was happy because it was a fast download, and of course the maintenance guys will like it because it's a straightforward, simple file to process. So it has a positive impact for all consumers of the data, and everyone in the process is much happier and much more effective in their jobs. So to summarize the need to simplify and the savings and benefits it can achieve, the simplification of mechanical CAD models ultimately leads to significantly smaller, more manageable files to push around the system and the process chain. It removes or eliminates repeated import failures, trying to import things over and over again, and how many people have, or how annoying is it to set off an import overnight because you know it's going to be a long import, only to come in the morning and find it's still sitting there or it crashed halfway through. If you can simplify the model, reduce the file size, you can eliminate that kind of problem. I know of a lot of engineers who receive very large CAD files. They know it's going to be a problem from the outset, so they automatically decide to remaster it or remodel it, creating primitive representations of the mechanical CAD model in their plant design system. Well, that's a massive overhead in terms of time. Another thing that to consider is we often hear engineers talking about squashed bugs or birds' nests on their layout drawings, where extremely detailed equipment models generate a mass of unintelligible, or a tangle of unintelligible lines in focused local areas. There's just too much detail on the complex equipment when compared to the size and the scope of the overall layout. It makes it unintelligible. So simplify the model, you could remove that problem. And another issue, or a couple of issues we see, are the stability and the usability of the plant design system with these very, very large mechanical CAD models integrated. We quite often see systems becoming unstable, slowing down, crashing or hanging. If you can reduce the size of the model, you can eliminate those problems as well. Ultimately, if all of those things work and you've got a smaller model, it helps you reduce your lead times on a project and ensure a quicker time to commissioning and a faster response to issues in the field. So these are some of the savings that can be achieved with CAD model, mechanical CAD model simplification. Now I want to look at some of the ways we can achieve that simplification with CADfix PPS. So just to give you a very quick overview, the CADfix model simplification solution has been in existence in various forms for over 40 years. Today, it is one of the leading solutions for CAD model translation, repair, and simplification. It offers multi-CAD import and export for most, or if not all, of the mechanical CAD systems in neutral formats, as well as faceted model representations. And it offers a wide range of advanced model simplification and repair tools. CADfix is well established globally in the aerospace, automotive, consumer goods, and electronics industries, where it is used to ensure the effective connection between CAD/CAM and CAE systems and minimizing the CAD rework and reducing project lead times. We've identified a clear need in the plant industry, the process, offshore marine, utility and power sectors to take these tools, adapt them, and apply them to provide a solution to meet some very specific model simplification needs. The type of features that we have that we can apply to the process industry are things like the removal of unwanted small parts, such as nuts, bolts, washers, gaskets, small brackets, that are perfectly feasible, genuine parts of the mechanical CAD model, but just not needed for the plant design or the layout. We can also see we have tools to remove CAD features such as holes, protrusions, blends, text or logos that appear on the CAD model. Again, genuine features that are in the mechanical CAD part for manufacture, but are just not needed in the plant design system and carry a massive overhead in terms of file size and handling. We can also remove internal parts. So this is just showing a gearbox with a gear assembly inside. But none of those can be seen from the outside with the gear casing on. They're probably not relevant to the plant layout. So why have them in the model? Just remove them. Run a process to remove those internal parts that cannot be seen from the outside. And then another operation is to simplify complex shapes. So complex cylindrical shapes or block prismatic shapes that really all you need for the plant design layout is a simple cylinder or a simple prism. So we can look to simplify those shapes. So that's some of the kind of operations we can do. I just wanted to look at a few of them in more detail. The first one, and the most obvious one, that can have a significant impact on the size of a model and is very easy to do, is automatically identifying and removing small parts, nuts, bolts, washers, plates that exist in the model. They're part of the CAD model, they're needed for manufacture, but they're too small and they're too detailed for the plant layout. I think nuts and bolts are a very, very good example. We see lots of cases where an equipment model contains thousands of nuts and bolts, all of which have been modeled in the mechanical CAD system with full detail. So thread definitions, small rounds on the nuts and on the bolt heads, totally irrelevant for the plant layout. So what we can do is we can automatically identify these based on a bounding box size, and if they fall within that size, you just delete them from the model. Another way you can do it is to select a part and then ask CADfix to go away and find things that are a similar shape and size within a user-defined threshold or percentage. So we can quickly identify the small parts by size or quickly identify them by shape and similarity to another part. There's also a facility to, if we bring in the product structure and those parts are labeled with text entities such as bolt, nut, ANSI, M8, M9, you can all quickly search through the product structure, identify everything with the same name and delete them with one click. So small part removal is quick, easy, and very effective in reducing file size. The other thing that we can do is the removal of genuine but unwanted CAD features. So logos, small fillets, rounds, chamfers, protrusions. You can see the detail on this model here with some text on the side, the bolt heads, some fillets, some rounds. Here's the model simplified. A very quick automatic process will simplify that to an idealized structure with cylindrical structures, prismatic structures, delete the small details, delete the logos that are not needed. Again, to give a much simpler form for handling in the plant design system. The removal of things like holes and internal cavities, again, can have a very, very big impact on the size of the model. Here we can see just a very small pipe assembly with internal diameters, internal faces on the pipes and the pipe bends, and then the flanges are present with all the bolt holes. You may or you may not need the internal pipe diameter for your modeling purposes, but you definitely don't need the bolt holes. And by removing those bolt holes and the internal pipe diameters, you could cut down by 50% the number of faces in the model. And again, reduce the file size significantly. And turning pipes into solid tubes is perfectly acceptable for most cases, particularly if you're using it for visualization within the whole plant. And it has a massive impact. I've seen examples of plant models with lots of pipe work in them that can be reduced by almost by 50% just by removing the internal diameters and the holes. Particularly when it's an entire plant with thousands of pipes. Another thing that's quite effective is the removal of internal parts. I frequently hear engineers talk about the need to remove the internals from a cabinet or a large container because they're not interested in what's inside. And it's quite often a large compressor or generator housed inside that is what makes the model massive and unmanageable. So here we have I think this was a test model called a storm water processing station, where all the detail is contained inside the cabin. And if we pull away the front of that cabin to look inside, we can see all of the equipment, the filters, the pipe work that sits inside, which is adding to the mass of data we're trying to handle. None of that's really required. So what you can run is an automatic filter to say, look inside, anything that you cannot see from outside, delete it. And if we do that, we end up with just the outer shell of the model, which is significantly smaller than what we started with, much more lightweight, and much easier to handle. You'll also notice that although we've taken out the inside, what you can still see are the pipes that protrude outside and the key location points, which are needed for the plant design. If necessary, we could go a step further. We could turn this just into a box, and that it depends on the level of detail and the realism that you want to see. But it does lead me into the next operation that we can do, which is the basic shape simplification. Plant design systems very often just want the outer envelope, bound in boxes or primitive shapes, and it gives something that's much easier to handle. Here we have a very example of a small motor, a gearbox, and a fitting attached to the gearbox, which was quite a big file. I think for what it was about a 5 megabyte file. But by very quickly running an automatic process in the space of, I think, 30 seconds or 45 seconds, this model gets converted to its outer envelope bound in primitive shapes, giving something which is way more easy to process and handle and exchange around the supply chain. I think it was about 0.5 megabyte when we're finished. So that's so far we're looking really at interactive, kind of semi-interactive simplification functions. They operate with a simple kind of find and fix approach that allow you to still quickly achieve some simplification. But what we clearly understand what people want is automation. So we have something called the automatic simplification wizard, which is an advanced intelligent process that brings together the operations we've been looking at, such as small solid removal, hole removal, conversion to primitives, internal detail. And it brings it together for a fully automatic model simplification process. It offers 3 levels of simplification, as shown by the 3 icons within the dialog box. So reasonable detail, medium, and very coarse level of detail. It offers user control with a series of options to say what processes, what do we want to simplify, what tolerances and sizes do we use. And those user options can be saved and configured for later use. It also has something called a keep list. Very often, engineers want to simplify the model but not touch this important feature. Do not touch this solid. It's essential. It has to stay exactly as is. So we can add things in, select things and add them into a keep list so that they're not simplified. And the whole thing, the simplification wizard, supports batch running. It can be called from the command line, use an options file to facilitate fully automatic batch running from the command line within a broader PLM simplification process. So check a model out, run a simplification process, plug it straight into my plant design system. So just to give you a quick summary of CADfix PPS, it's based on the well-established CADfix technology that's been around for a number of years, that has now been applied to the model simplification issues faced by plant and process, utility, marine, offshore, and other industries. It offers advanced automatic simplification through the wizard, which is then backed up and supported by a set of manual interactive simplification tools. And users can select which they prefer to use. A lot of our customers just work with the automation, but several customers just have particular types of models and they know they only need to do 2 or 3 manual processes to achieve the simplification they want. They might just go in and use those simplification processes. But those tools have been specially presented in a simplified, easy-to-use interface to help engineers tackle the simplification of large equipment models. So that's talking about kind of some of the options and features that it has. But let's just look at a couple of quick representative examples. The first one I have here is a large skid assembly. This is what I used in the illustrative workflow example earlier on, where the original mechanical CAD model has been exported as a 798 or 800 megabyte step file with 3,000 solids and 141,000 faces. So it's a big model for just one of many skid assemblies that you're going to put into a plant layout. Process the model through CADfix. The resulting file is a 29 megabyte step file, so down from 798 to 29. 3,000 solids down to 590, and 141,000 faces down to 8,500. That's about a 96% data reduction with 20 minutes of processing time. I think anybody watching would see the benefits they would get through using that simplified model compared to trying to deal with the import and the processing of that original step file. Here's another example, which is another equipment assembly. These are real examples from customers that we were able to process and show. This one's slightly smaller. It was a 37 megabyte DWG file, something you might get out of AutoCAD or out of Inventor. A 37 megabyte DWG file with 61,000 faces. We processed that through. The result is a 3.7 megabyte file. Actually, it says step file, but it was a 3.7 megabyte DWG file with 3,500 faces. So here we were seeing a 90% data reduction in 25 minutes. Again, the benefits of running that model through an automatic process, getting the data reduction, and giving you something much more usable in your plant design system. And another thing we see quite often is stairs and platforms. Here's an example, just a thumbnail image of a small stair and platform assembly. I've zoomed in on a local area to see it. But before, the model was a 72 megabyte SAT file with 26,000 faces. After CADfix has processed the file, we've ended up with a 4.8 megabyte file with 4,700 faces. We got again, about a 93% data reduction with 20 minutes of processing time. And one of the reasons for zooming in on the local areas here was to see the floor grating panels and the stair panels. Very often these contain a massive amount of data that is again not really needed in the plant design system or carries a massive overhead in terms of file size. And mostly those can be reduced to rectangular prisms, a six-sided box with a fraction of the amount of data contained inside them. So they're just three examples of the kind of things that you can achieve. But I think what I'd like to do now is, if I hand over to Kurt from Kiewit, he can talk a bit more, put the whole thing in the context of a real customer application. Talk about his company's requirements for CAD model simplification and the key benefits they're seeing from the deployment of a simplification tool. So, Kurt, over to you.
Thanks, Andy. My name is Kurt Johnston. I'm the CAD applications lead here at Kiewit. I've got my partner in crime, John Elliott's here with me. We basically manage all the models for the plants that Kiewit works on here in our energy group. And that includes all the vendor models that we get, our construction models, details, things for clash detection. We also use the models for rendering, things like that. So kind of a little bit of background on our work. Kiewit's involved in power generation, transmission and distribution projects all across North America. We support various engineering applications. Our main platform is SmartPlant. It's an Intergraph application. But we also use Navisworks as well as a few other MicroStation, Bentley related and Autodesk related products. So we run the whole part of different models and different file types and stuff. Part of our task is to always improve the design process. Kiewit works very closely with our construction partners. We actually have one of the largest private construction fleets in North America, so we are in contact with the guys in the field every day. So once we start sharing models and doing that more and more, the way that businesses run these days, it's very important that we improve that process as much as possible. The ultimate benefit for our design process is for our clients to improve our design efficiency, improve the construction process, and obviously the overall project cost. So this case study that we developed using CADfix was a key part of that. Part of our requirements, we work with multiple vendors. We actually do a lot of the coordination in the plant ourselves, but we have a lot of vendors that supply a lot of the equipment, things like that. Our contract documents specify the level of detail for most of those models that we get, but as you can assume, a lot of the clients that we have, their bread and butter are their products, or their machines or things like that. So they're obviously going to be as detailed as possible for their use. In most cases, once we get that incorporated into our overall model, a lot of those details aren't as important. They obviously are for coordination purposes, but for the overall part of it, we try to simplify those as much as possible. A big part of that is that level of detail in our clash detection process is really not needed. So like Andy mentioned, the nuts and bolts and holes and some of the interior parts to the larger structures aren't really needed when we're doing clash detection. So simplifying those models really helps out a lot. By doing so, this reduces the time and complexity of the overall project model, and I'll get into more detail about our testing that we did for using CADfix on a lot of this stuff. And I noticed one of the questions Gary Jones asked about having a separate file with the more details before the analysis goes. We do keep our original vendor models, and we also have an overall detailed model that leaves all that intact, but for our coordination and clash detection purposes, we use the simplified model and keep those as separate entities. One of the examples that we looked at, and for people in the power industry, they'll know what this is as far as the STG. Our original model that we got was over 400 megabytes. After reducing it through the use of CADfix, we reduced the file size alone to 95%. This resulted in a 22 megabyte file. This is one of those things that the overall STG is a main component of our plant, but it's not necessarily one that we need that much detail for our coordination and our clash detection. So simplifying this was a huge plus for us. The second one, and Andy kind of touched on this too, was the grating, the steel grating for steps and walkways and things like that. As you can imagine, our power plants and even some of the other products that we design uses steel grating quite a bit. But in the overall model, a lot of that steel grating and the number of facets involved with that is really not as important when you're talking about the clash detection and the detail in that model. So in this case, we had a pretty good size. About a 49 megabyte file had 13,000 faces because of the steel grating. After reducing that through CADfix, we reduced the file size by 94% and reduced the number of faces down to 1,400 versus the 13,000. So that's quite a savings, and as far as time goes, that makes a huge difference on the preparation of the model. The last one we had was another model. This one is fairly complex. It was about a 300 megabyte file. We reduced it down to 52 megabytes. There you can see in the left one in the original analysis, there were a lot of coordination parts to that really weren't necessary as far as the overall model goes. But for this SKIDPACK, it was obviously very detailed so that they could build what they needed to, and then we simplified it down for our overall model. Part of our analysis is we took the model that you saw there, we took each one of those through a different comparison. We did a file size comparison using our SmartPlant product. The resulting conversion file that allows SmartPlant to do its thing is called a view file. We looked at the size of those converted files. We also recorded opening time when we have 50 to 60 designers and engineers on any given project that are opening this file every day, sometimes multiple times a day. And when you consider it takes anywhere from 1 to 3 minutes to open up the overall model, any time savings that we can realize using a simplified model can be huge. The last one we recorded was memory usage. We wanted to see how this process with the simplified models affected our hardware and the use of memory to determine if we really needed more memory on a lot of our machines that people seem to request every day. But you can see we tested this in SmartPlant Review. We tested these files in SmartPlant 3D, and we also use a product called Universal Plant Viewer. It's a UPV. We tested the same parameters in that product as well. Just under SmartPlant Review, we saw realizations in file size down to 95% of the original file size after post-processing. That resulted in a 80% savings in a view file size. Most of the time it was anywhere from 30 to 70% opening time. And again, when you consider 50 people and we're shaving 15 to 30 seconds off every time those 60 people open this file, you're saving a few hours every week, and over the course of a 2 or 3 year long project, that's considerable savings just in time alone. The memory usage, we did notice a few of the models. We reduced the memory usage and the demand on the hardware by as much as 80%. So that what that told us is there's a lot of times that the memory that we had in our hardware was adequate. In some cases, we found out where we were lacking on some other products, so we ended up changing our parameters for some of our hardware as well based on this testing. One of the interesting ones is on Universal Plant Viewer. This is a product from CADfix out of Denmark, I believe, or Germany. We saw some of those file sizes reduced by at least 90 to 100%, which is pretty amazing. And just the way that product is actually built on a gaming engine. So when you talk about reducing the facets and the complexity of the models, it goes a long way towards improving the performance in the UPV model. A lot of these models, again, we share with guys in the field, so they're pulling these up on tablets and in some cases on their personal phones. So when we try to simplify these models as much as possible, it makes for the data transfer a lot more quicker, a lot more less painless, and also opening the files and navigating through the files when you're doing coordination and clash detection. It helped improve that quite a bit. Kind of recap the benefits that we found using CADfix. This obviously saved time opening files over the network and our mobile apps. It saves time in our daily model coordination activities. This was realized by a lot of our engineers and designers as they're doing their daily model walks, just seeing the improvements in performance there. We in turn maximize our memory usage in our standard hardware builds. A lot of these models have simplified our clash detection. You can imagine trying to clash a pipe with thousands of nuts and bolts, and we reduce those nuts and bolts, and it takes our clashes down to the important clashes that we need to see. And we saw this similar benefits across multiple design platforms. So this wasn't just one product that we are looking to use CADfix and apply all the benefits to it. This was across multiple platforms that we use for different vendors, different file types, different projects, you name it. We saw some realizations for quite a few of those. So. And I guess Andy, we'll turn that back over to you. And
yeah, thanks for that, Kurt. It's always fantastic to hear of an end user application of the software and the benefits that we're getting, just to know that we're kind of hitting the right marks for what it can do, and the benefits you can get. And I hope that we've provided an interesting webinar and given you a few ideas about how you can use mechanical CAD model simplification to great effect within your own digital model processes. We firmly believe that there's a clear need for model simplification. I think, as was illustrated by Kurt, there's a clear need for it, and that it can result in both qualitative and quantitative business benefits, things that will enable you to eliminate the manual processes that affect some of your late-stage design work, mitigate against project delays, enable you to meet the handover or commissioning milestones, maybe even benefit from payments for early delivery as against penalties for late delivery. Simplifying the models means you can reuse them across different plant design systems and multiple projects with a lot more capability and smoother integration. And you also see the broadband costs removed for mobile applications. So I would say don't hesitate to contact us if you want any more information about how CADfix PPS can be used and the type of simplification we can do. We've got a US head office in Europe and in the UK and Germany. We also offer we're very confident in the ease of use of the product and how quickly people can get working with it, such that we offer a free downloadable evaluation of the software. So feel free to contact us for more information on that, and we can provide you with the links and further details as needed. So thanks again to Kurt from Kiewit for joining us on the webinar, and I'll hand over to Rod now so we can take any questions.
All right, thank you, Andy, and thank you, Kurt, for a great presentation. A lot of good real-world examples there that really help down the road towards commissioning. Fantastic stuff. It's now time to move on to the question and answer portion of today's presentation. Those of you who have asked about the PDF, you should see a poll popping up soon that asks if you want a PDF of today's presentation, and if so, our presenters will email it to you after the presentation. Now, if you haven't done so already, please enter your questions by clicking on the Q&A widget and typing it in. Kurt and Andy will respond to as many questions as time allows. And we'll get started here. First question we got here is, make sure there we go. Looking at, first question up here is, what is the licensing structure for CADfix PPS, network or individual machine?
I'll take that one. So the license is controlled by FlexLM or FlexNet. We do offer a node lock license. These are all single user counted licenses. You could have multiple user licenses if you need more licenses. We offer a node lock license. We also offer a network license, which is installed. The license server is installed centrally, and the license can float around multiple machines within that network to run CADfix locally. So node locks or network licenses. And the network licenses are available as local area within a single company site, wide area within a country. We have a regional network license, so to cover North America or Europe or Asia Pacific. And we do have a global licensing structure as well that we can offer.
Very good. Thank you, Andy. Another question up here is, what CAD data exchange file formats does CADfix accept?
So CADfix will read most of the common mechanical CAD formats, so things like CATIA, Siemens NX, SolidWorks, Creo, Inventor. We read all of those native formats, and we also support most of the common neutral formats that are used to translate data, things like STEP, Parasolid, JT, DWG, ASYS-SAT. We also have support for, although CADfix normally focuses on processing solid models, We also have support for faceted model definitions. So where a model has been tessellated for export to a plant design system, we can read those faceted models, simplify them by reducing the triangle count, or we could export a mechanical CAD model to a lightweight faceted format, such as STL, FBX, or DWG faceted. So I think we cover most of the mechanical CAD formats and derivatives that you'll need.
Excellent. Thank you. That helps a lot, I'm sure. So next question is here, how do we ensure that there is no data loss of required items in the model? Do we have any control?
There is quite a bit of control. The automatic simplification has full user control. So you can turn on or off particular functions that you want to use. You can control the tolerance, for example, what you would deem to be the size for a small object. You could specify the box size. You could specify the hole size you want to remove. And you can also identify parts based on maybe the label or by manual selection to put into a keep list so that then they are not simplified. So there's quite a bit of control. Ultimately, we like to keep the user in control. So he has the options to change the amount of simplification that is performed, and you may decide, based upon particular types of models, to have different configuration files with different options and tolerances to process those models.
Excellent. Thank you for that, Andy. Next question, pretty straightforward one. Does the software work with Siemens Teamcenter?
CADfix PPS is a standalone application. It runs as an interactive product, but it can also run as a command line batch product. In that case, it could be called from a Teamcenter, called within a Teamcenter workflow. We do not have a direct integration today to plug into Teamcenter, but you could write a Teamcenter dispatcher process or other Teamcenter process to call CADfix in batch.
Thank you. How about MicroStation DGNs?
Unfortunately, we don't have support for the DGN format today. It is something on our wish list. We are looking at options for that, but today we do not have support for DGN.
All right. Next question, is there any hardware specifications required to run CADfix?
There is a minimum hardware requirement, but I would say any technical PC that you're using for mechanical CAD work or plant design work will handle the processing. A typical out-of-the-box laptop today with 4 cores and 4 gig of memory would do the job.
All right, thank you. One of our audience asks, do you have support for IFC format?
We've been working on that this year. We have a prototype IFC import, which although it's prototype actually seems to be doing a pretty good job. We haven't taken that to full production yet, so it's we have something, and there will be something in production fairly soon, I hope.
Great. We have some great questions here. Another great one's coming up here asks, will it support my workflow on Revit, considering the workflow of LODs?
We don't. So our level of detail specification is controlled by the icons in the simplification wizard, the 3 levels of detail that we have there. And each of those 3 levels of details have associated options and tolerances that the user can define. So whilst they're not explicitly linked to a particular Revit level of detail or workflow, they can be tuned by the user to match the settings they want.
Wonderful. Thank you, Andy. The next question is, what is the maximum size of file which the software accepts?
Well, I've processed there isn't a hard and fast limit. I've processed files in the gigabyte range. They obviously take longer, but I think 1.5 gigabytes was a file I've processed. They will take longer to process and to simplify, but I think the main limitation is machine limitations there.
Gotcha. Okay, good to know. How often is the software updated?
We generally do a major release once a year, with at least 1 or 2 service packs as well within the year.
Okay, good deal. Now, let's make sure I get to work through all the questions here. Is CADfix available for a free trial?
Yes, it is. Traditionally, we've been very reluctant to do things like that because software normally needs training to be able to use it effectively, and so that people get a good impression and also don't waste their time. With PPS, we've been very careful. CADfix PPS, we've been very careful to streamline the user interface and provide a workflow that is easy to pick up. So we offer CADfix PPS as a free downloadable evaluation. It comes with a short tutorial and some test models and access to some videos. And we have very good feedback and reports from people who pick it up and try it.
Okay. Now, got a very important question here, and this is: can you review the simplified CAD model within the CADfix, or do you have to open it with other CAD software?
It's all done within CADfix. So CADfix has its own viewing capability. You read the model in, you can assess it, you can specify the tolerances and settings within CADfix, and then when it's finished, you see the final result. We also have an undo button. So if you don't like the simplification, you can press a button, undo it, change the options, and run it again.
Okay, thank you for that. Is this a 32 or a 64-bit program?
It's developed in 64.
Very good. For your use cases, is it important to keep the simplified models updated when source CAD files change?
Some customers want to do that because some of the key location points might have changed on the updated CAD model. I might throw that one over to Kurt, because in a production environment, he's receiving updates of CAD models, and he may have a specific process or preference he uses there.
Yeah, we do try to keep those updated. And to kind of help answer a couple of questions there, we do spend a little bit of setup time on each vendor model and whenever the updates come in. But we also have a set tools that once we have the settings that we want, we save those per vendor. So when we get a new vendor file, we can basically run it with the same settings, and it reduces the time after we've done the setup time to just run with those same settings and do the same simplifications that we did the last version that came through. But we run those updates nightly in case there is something new that comes in, then just to make sure they're all updated in the existing model.
Okay, thank you, Kurt. What is the licensing structure for CADfix PPS? Now, this sounds very familiar to a question we may have already asked. Is it a network or individual machine?
Yes, similar to what we answered before, but I'll mention it again. So we have a node lock license, which is a single user license to run on a specific machine, and then we have a network license, which is a single user license to run on multiple machines within a network, which could be a single site with also options for single country network, regional networks, or global networks. Excellent.
Well, yeah, we're getting up to the top of the hour here, so we basically got time for 2 more questions here. And this one asks, is there a dynamic link from the master to the simplified model?
No, I'd say we start off with the original CAD model inside CADfix. We simplify it. They are different. They are changed parts or changed models. We can undo and go back. We have some links deep down inside CADfix where we know that this simplified part came from an original complex part. but it's not something you can quickly switch between in a live session. You've either got the original model or the simplified model. But that's quite a good idea. If we had a dynamic link, we might be able to select a part that's been simplified and just say revert that back to its original. So I'll take that one away as a good suggestion.
Excellent, excellent. We learn from each other. So the last question here, and this gets to my bargain-loving heart, which is, are the updates free?
They're free if you pay for them. Let's put it that way. No, if you have we have an annual term license, which means basically a lease license. The user has it for a year. That annual term fee includes maintenance, updates, and end user support. We also offer a perpetual or indefinite license, where a user pays a one-off license fee, which gives them an indefinite right to use the software. And there is then an associated annual maintenance, enhancement, and support fee. And if the customer is paying the annual maintenance, enhancement, and support fee, then they get all updates and bug fixes included in that annual term period.
All right, great to know. We've got a lot of great questions here, but unfortunately we're running out of time. So I want to thank the audience for all of those great questions. If your question was not addressed, one of the speakers will look at it offline and respond to you via email. And on behalf of Power Engineering, as well as our parent company, Clarion Energy, I would like to thank today's presenters, Kurt Johnston of Kiewit and Andy Chinn of ITI UK. I would also like to thank ITA for sponsoring today's presentation, Simplifying Large CAD Models for Plant and Process Design. And remember, this presentation will be archived within 24 hours and can be accessed from the homepage at power-eng.com. A reminder email message for the archive will be sent to all of you who are registered. It will include a direct link to the archived webcast. Please feel free to share that link with your coworkers and peers. I want to thank all of you for joining us today. I know you're very busy. We appreciate you taking the time for this great presentation and look forward to sharing future webcasts with you. I'm Rod Walton for Power Engineering and PowerGen International. Have a great day, everyone.